Hi, this is Mrs. Dorn, and I thought I'd do a little bit something different today. Instead of presenting to you in lecture mode in front of the class, I thought what I would do is present it via internet. The reason being is we have quite a few people who are gone off and on lately, so this is the easiest way to reach you all at once. Now last week we began simplifying square roots, such as the square root of 180. In order to do that, we looked at our list of perfect squares and we decided what was a perfect square that went into 180. Now there are several different ways to do this. I'm just going to go with something kind of simple. I'm going to start by taking 180. I know it's divisible by 2, so maybe I'll divide it by 4. 180 divided by 4 breaks down into the square root of 4 times the square root of 45. But wait, 45 has a perfect square that goes into it. So let's think about that. Well, the square root of 4 is 2, so that's no big deal. Square root of 45 I know is 9 times 5. Well, the square root of 9 is 3, so 2 times 3 times the square root of 5, and 5 is what we call a prime number. It doesn't have any pairs, so we leave it. So the answer is whatever 2 times 3 is, which is 6, square root of 5, and that is the exact answer. Let's try another one. Well, I know that square root of 350 has to be divisible by 25, so I'm going to start by dividing it by 25. 350 divided by 25 is 14. So we say the square root of 25 times the square root of 14. Now the square root of 25 is just 5. Square root of 14, 14 is 2 times 7, which are neither of the two are perfect squares. The only other way we could get it is 1 times 14. So it can't be broken down anymore. So it's just 5 square roots of 14. So that is simplifying. Then from there, we went to actually condensing them together. Now I told you could try to reduce before you start, but the easiest way to go about doing this is to go ahead and multiply the numbers. 6 times 21. Square root of 126. Well, I know 126 is divisible by 2. Is it divisible by 3? Yes, it is. So it's probably divisible by 6. 21 times, which I already knew that. But 6 is not a perfect square. Well, let's try 9. 126 divided by 9. 14 times. That sounds good. Square root of 9 times the square root of 14. Well, just like before, I said 14 couldn't be broke down, so it's 14. The square root of 9 is just 3. Let's try again one more time. 22 times 8. I could go ahead and simplify anything that I want beforehand, or I could put them together as one math problem. So I'm going to do 22 times 8, which is the square root of 176. Well, I know 8 is divisible by 4, so maybe I'll break it down. So 176 divided by 4, well, that's the square root of 4 times the square root of 44. Square root of 4 is 2 times, well, 44 is 4 and 11, so square root of 4 times the square root of 11. Square root of 4 is 2, so it's 2 times 2 times the square root of 11, which is 4 square roots of 11. And I can't break 11 down because it is a prime number. After we multiplied, then we began with division. And we talked about rationalizing the denominator. If I look at the first one, I have 7 divided by the square root of 14. So top and bottom is going to get multiplied by the square root of 14. Reason being is 14 over 14 is just like 1, so that is okay because whatever we multiply the top by, we can also multiply the bottom by. 7 square roots of 14 just kind of gets mushed together. It becomes 7 square roots of 14 times the square root of 14 times 14 is 196. Well, wait, I know that 7 square roots of 14 can't simplify because 14 is that funky number that has only 2 and 7 or 1 and 14. But I know the square root of 196 is 14 because it was 14 times 14. Now we're not quite done yet with this problem. We've introduced 2 whole numbers right here. So what we need to do now is we need to reduce those numbers. To do so, we take, what is 7 over 14? Well, that's 1 over 2. So you can put up a 1 up there. So 1 square roots of 14 over 2, or you could just put the square root of 14 over 2. Now, sometimes in math, we get a problem and say, okay, I'm going to go right ahead, multiply by the square root of 3. Square root of 21 divided by square root of 3. But just about like breaking things apart, sometimes it's better to put things together. Square root of 21 over the square root of 3 is really like saying the square root of 21 divided by 3. Well, 21 divided by 3 is 7. So really it's just the square root of 7. I can have the square root by itself. It just can't be in the denominator. Now, what if I didn't realize that? Well, let's see. You would have taken square root of 21 over the square root of 3 times the square root of 3, square root of 3. You would end up with square root of 63 over square root of 9. Then you would have said, oh wait, 63 is square root of 9 times the square root of 7 over square root of 9, which is just 3. Square root of 9 is 3, so 3 square roots of 7 over 3. And then, hey, look, 3 over 3 is 1. They cancel. There's my answer, square root of 7. A lot more work. You get there. It's just sometimes it's easier to look at the problem before you start. Now, when we divided 7 divided by the square root of 14, we couldn't combine them both together because they both did not have a square root. You can only combine them if it's a square root on the top combined with a square root on the bottom. Let's look at some that are already put together. Well, just like putting things together, you can actually break things apart. So if I look at this one, square root of 2/9, it's like saying the square root of 2 over the square root of 9. Well, the square root of 2 is just the square root of 2. Square root of 9 is 3. Now, I don't have to go any further because we no longer have a square root in the denominator. And the square root of 2 is prime, so I just leave it. Let's try another one. Square root is 6/5. Square root of 6 over the square root of 5. I multiply top and bottom by the square root of 5. Well, square root of 5 times the square root of 5 is the square root of 25, which is just 5. Square root of 6 times the square root of 5 is the square root of 30. Well, 30 is divisible by 1 and 30, 3 and 10, 6 and 5. If we use the 10 one, that was 2 and 5. So there are no pairs, so that is my answer to my math problem. Hopefully this is helpful. I've added just a little bit to it, but this ends video 1 of simplifying square roots.